Insertion sort. Insertion sort is a simple and intuitive sort method. As the name implies, it systematically picks array elements and inserts them into proper positions. The array is proportionally divided into two regions, one with sorted items and other with unsorted items. In each pass, an element is picked from the beginning of the unsorted region and moved into the sorted part. In order to do so, all elements larger than the element being moved are shifted one position to the right to make room for the picked element. Figure illustrates the insertion sort procedure on an array consisting of 5 elements. To begin with, the first element 83 is considered as belonging to one element sorted region. The second element is then moved and placed before 83. This insertion requires 83 to shift to the right. In fact, 83 occupies the position vacated by 22. Next, element 29 is considered. It would need to be inserted between the elements 22, 83 in the sorted region. Thus, element 83 is moved one place to the right to make room for the element 29. In the next pass element, 77 is considered. It would need to be inserted between the elements 29, 83. To do so, the element 83 is shifted to the right. Finally, element 67 is processed. It is placed between the elements 67, 83. The array is now in the sorted order. Please click the button to watch Insertion Sort visualization. Implementation of Insertion Sort. Insertion sort can be implemented in different ways. A simple procedure uses two arrays, one to store the source data and other for insertion of sorted elements. To save storage space, it is usual to use in-place sort, which uses a single array for sorted and unsorted items. In fact, the approach was followed in the insertion sort examples discussed previously. The source code for insertion sort procedures for in-place sorting is given in figure. It sorts an array of floating point numbers stored in array X of size count. The procedure is based on two nested loops. The outer loop controls the passes over the array. The inner loop iterates to perform comparisons and does the shifting by moving an element to the right. The variable temp holds the elements to be inserted into the sorted sub-array. Please click button to run interactive program for insertion sort. Analysis of insertion sort. The preceding discussion shows that insertion sort method utilizes two loops. If n is the array size, its outer loop makes n-1 passes over the array. For each pass, the inner loop makes one or more iterations to make comparisons and shift the data. In the worst case, when the inner loop is fully executed, it makes 1 plus 2 plus up to n-1 is equal to n-1 by 2 comparisons and equal number of shifting in each pass. The outer loop assigns an element to a temporary variable and then assigns the temporary variable to an array element. Since outer loop execute n-1 times, it causes 2 n-1 data moves. Thus, altogether, the insertion sort performs n-1 plus 2 n-1 is equal to n square plus n-2 operations involving comparisons, shiftings and assignings. Thus, running time of insertion sort is O(n) square plus n-2 or O(n) square. More precise analysis would show that on the average, insertion sort makes about n square by 4 comparisons and n square by 8 exchanges. Thus, even though insertion sort has quadratic runtime, it performs better than bubble sort and selection sort. It is, however, inefficient for large datasets comprising several thousand data items.